Hi everyone, Happy New Year, and today we'll be solving the question majority element 2, which says that given an integer array of size n, find all elements that appear more than n by 3 times. So we are given an array of size n, and you have to find all the elements. It can be more than 2 or 2 elements that appear more than n by 3 times. So previous video I have solved the question majority element, which was 1. Like we have to find the appear elements that appear more than n by 2 times. But in this question majority element 2, it says that find all the elements that appear more than n by 3 times, right? So the brute force, what it comes to your mind, like we will take an ordered map, right? And I will store it in the map, right? And then after that we will check whether all of those elements are appearing more than n by 3 times or not. This is the simple brute force that comes to your mind. I hope so. So this was a simple brute force, right? So I've taken an unordered map, and then I've stored the frequency of those elements in the unordered map, and I've taken a vector int m, and after that I'm checking the final okay, which checks the condition. It should be n by 3 times. Then again I'm iterating in the unordered map, and the first int is the elements, and the second int represents the frequency of those elements. Therefore L is equals to cc dot first, and L int count is equals to cc dot second, which is the frequency. I'm checking the frequency is more than okay or not, which is n by 3 times or not. If it is more than that, then please to store that element in the vector m dot pushback element, and then finally returning the m. So the time complexity here is big of 2n, 2 for loops, right? And the space complexity here is big of like one for the unordered map and another for the final vector. So big of 2m of this first, and then again this vector. So this was a simple brute force. So if you see, this is that majority element 2. If I have remembered, in the last question we have solved the question using a Boyer-Morse voting algorithm, which is basically that algorithm is basically used to find the majority element. Any question, if you see any question which says that find the majority element, okay, just remember of this algorithm, which is Boyer-Morse voting algorithm. Now I will teach you what is this voting algorithm, how, like, what are the rules for this voting algorithm. Simple, it's a voting algorithm, therefore there will be something called as count, right? So I've taken count is equals to 2. So the rules are what, like every time you will come across a number, you will just counter will be plus plus, okay? This counter will be plus plus, c plus plus, and the counter is equals to plus plus. So first element is 1, so counter be like 1 plus plus 1, and then again 1 is present again, so counter becomes now 1 plus 1, which is equals to 2, right? Now again, the second rule, if you see a number which is not same as the element, it was 1, now it is 2, therefore counter will become minus minus, so it will become 2 minus 1, which will become 1, right? Now counter is equals to what, 3, so again counter will become minus minus, it's not the same element, right? So counter becomes 0 here, 1 minus 1, again the counter becomes 0. So these are the rules, like, and when again the counter is 0, we will start from the first. Like see, for this, okay, so now its counter is 0, okay? So if first rule was whenever a new element is coming, counter should be plus plus, and if the element is not same as that earlier element, then this counter will be minus minus, right? We have did twice minus minus, and the counter is right now at 0. Again a new element came, and when the counter is at 0 and a new element appears, previously the counter was not at 0, counter was having some value, right? But when the counter is at 0 and a new element comes. Just remember, just hear it properly. If the counter is at 0 and a new element of course comes, then counter will start take that element. Element will be changed. Okay. 4 will be the new element. And so therefore counter will be adding. 4 3s are there. Okay, so it will become 1 plus 1 plus 1. For 4 there are 3 numbers are there, right? 3 fours are here. So counter is currently at 3. So now again if we end of the array, simple, just return this. As simple as that. So the rule one was that whenever you come to a element, then counter will be plus plus. If the element is not that element, then counter will be minus minus. And the rule 3 is at any time counter is 0, then the element will be changed and the counter will again start from the first. It will take a new element, that is we have taken a 4, and the counter will start from the first initial. That is 1 plus 1 plus 1, this is equals to 3. And so it is like n by 3 times. Therefore it can be like there can be 2 elements. The previous question there can be like half of the, it was like n by 2 times. Therefore one element will be only present, n by can be present in that n by 2 times array. Therefore I have taken one counter, but it says that n by 3 times. Therefore I will take 2 element can be, see it says now all the elements, that means there can be multiple elements which is present n by 3 times. So in my brute force approach, I will be taking like 2 counters. Since my code was a bit, critical, a bit complex to understand, which is this one, I solved in the month of June. Therefore, I am taking, I've taken this code from ChatGPT, which is very simply for you to understand. Very simple. I have told you the reason why I have taken 2 counters here. It is n by 3 times. Therefore, 2 counters, counter 1 and counter 2. So now, simple, if num is equals to that candidate at the first element, then please counter 1, please plus plus. And if it's a different element, then counter 2 also please plus, get that. Add that element. Counter will increase by 1. At any point, counter is equals to 0. So at that time, num will be changed. Candidate 1 will become that particular. Suppose at this point, if the counter was 0, suppose at this point. So 2 will become the new element. That's why I have done candidate 1 is equals to num. As simple as that. And then counter 1 is equals to 1. Now counter 1 will again start from 1. Right? Then only it can be added initially. Again if 2 comes here and like that. Same for candidate this one. At any times the counter is equals to 2, I will change the element. Candidate 2 will have a new num. And then I will also initialize at 1, by increasing the incrementing it by 1, that its frequency is 1. If it's not the same element, rule number 2, then counter 1 will also be minus minus and counter 2 will also be minus minus, right? Now this is for the final check, so that we do not miss. It's like an extra check. If this number candidate 1 is equals to 2, and then this for the final check, this part is done in this particular question only. If num is equals to candidate 1, then please counter plus plus, so that to avoid such mistakes. This is an extra step we do here. And then finally result, if the first counter 1 is more than n by 3 times, then please result take that and candidate 1 element and then push it. If counter 2 is more than, then result please take that element and finally return the result. Of course, this is having a time complexity of big O of n. See only, okay, big of 2 for loops are here, right? Therefore big of 2 n and this space complexities. Do not think that this is the simple. It's just storing the result like almost big constant, right? So you can say big of 1 also. So I hope you understood the solution, and if you read, then please keep lit coding And thank you so much for watching. Bye.